Okay, so lastly, we had just figured out that the wavelength was 4.17 times, or 4.16 times 10 to the negative 7th meters. And if I could also ask you to find the frequency. Well, if I have wavelength, the equation to find frequency would be C equals frequency times lambda, or wavelength. And so I'm going to solve for frequency, so I'm going to divide both sides by lambda. So frequency is going to equal the speed of light divided by lambda, which the speed of light is still 2.998 times 10 to the 8th meters per second. And I can divide by 4.16 times 10 to the negative 7th meters. And so 2.998. Oh, for some reason I have an extra little 1 in there. Oh, I forgot. No, it's an extra little 1. There's not a times. Times 10 to the 8th meters per second. Divided by 4.16. Second function exponent, negative 7. So it's 7.1989, or 7.20 times 10 to the 14th. And notice your meters cancel out, so you have a seconds in the denominator, so that's seconds to the negative 1. Our name for that is hertz, so I could say it was 7.20 times 10 to the 14th seconds to the negative 1, or hertz, which is H-E-R-T-Z, or H-Z. Could also call it cycles per second or wavelengths per second. Remember, when you're talking about visible light, and this is visible light or very close to it, that your meters will always be 10 to the negative 7th. Your hertz will always be 10 to the negative, or positive 14th, sorry. And your energy, your joules, will always be 10 to the negative 19th. That's only if it's visible or close to it, but that's a nice check if you know something's visible light. That's how you would do that as well.